This lesson of translations, we're going to talk about rotations. And so I like these two pictures here because they have some type of rotational symmetry, which we're going to talk about at the very end. So when we think about rotations, we think about objects that are spinning and going in circles. By definition, a rotation is going to be a transformation that turns an object, right, about a fixed point, and that fixed point is called the center. And we've seen this term center before when we had constructions with the compasses, because the compass had a point and like a location on it called the center, and that's where we would put our finger on top of it, and the circle, the compass would spin around it. So when we have that location, that's called the center. The center of rotation then is that exact point that the figure rotates upon. So that becomes important, as we'll see in a little bit. We're also going to see this idea called angle of rotation. So if something has some type of rotational symmetry, we can measure how many degrees it takes before it becomes itself. And so we'll see that in a little bit. One thing to keep in mind is that in math, positive is going to be counterclockwise. A lot of times you may not see a negative number, but the problem will give you a clockwise rotation, which means we're going opposite. So keep that in mind as I show you what's coming up on the next examples. So here's an example where we're given 3 coordinates and we want to rotate this 90 degrees about the origin. And if the problem doesn't tell you which way, we assume that it's counterclockwise. Okay, so in this case, this is going to be 90 degrees counterclockwise. So when we plot these 3 points here, we have a triangle. So what we're going to do then is, this section here is not in your notes, so definitely make sure you have this added to your notes. These are the rotation rules using arrow notations. So for 90 degrees, which we're going to use, if we take our original x and y coordinates, what we're going to do is switch places of the coordinates and then change the sign of the y value. So for point A, for example, it's -1. So we're going to switch locations and the y value is going to change. So this should be a +1, +5. If we go from B here, it's 1, -2. So we're going to switch locations and then change the sign. So this should be a +2, +1. For C, we're going to switch locations of it, and the -4 becomes a +4, and then +3. So that would be the 90-degree rule. Okay, so again, we switch locations and change the sign of the y value. Okay. All right, the other rules that we're going to use throughout this unit, 180 degrees are going to be the x and y stay in the same place, but the signs change. And then for 270 degrees, x and y are going to change places, and the x value will change signs. Now, this is important because these rules are based on counterclockwise rotations. So if the rotation was 90 degrees clockwise, that would be the same as 270 counterclockwise. Okay, that means 90 degrees counterclockwise will be the same as 270 degrees clockwise. So keep that in mind. Now, 180 degrees is the same no matter which way you go. And oftentimes when you see 180 degrees used in a problem, it doesn't give you a direction because it doesn't actually matter. So what I recommend you guys do for this is to keep in mind the rule and then what actually happens. I think if you use it in words, that might be a little bit easier than in the symbols. And then that way you can figure out how to adjust the coordinates. Let's take another example. This time we're going 270 degrees around the origin here. Okay. So the rule then is going to be we're going to change locations and change the sign of the x value. Okay. So this point here, A, is at 0, 2. 0 is the x value, 2 is the y value. So we're going to switch locations, okay, and then change the sign of the x value. But because the original x value is 0, you can't change the sign of it with the positive or negative, so it just stays 0. That is the only case when we change signs, the number remains the same. All right, if we go to T, T is -3, 0. So we're going to change locations and then change the sign of the x value. For H, we're going to change locations of the coordinates and then change the sign of the x value to make it a positive. All right, and then for M, same thing, change locations and then change the x value. And so now you have your coordinates here, your prime coordinates, and we can graph them to get the particular graph. All right, the last thing we're going to talk about is rotational symmetry. So in the beginning lesson, I had those shapes that looked like they were symmetrical in rotation. Okay? So this, by definition, is a figure. If it has rotational symmetry, it's a figure that can be rotated 180 degrees or less and equal itself. So if you were to turn it, it would be the exact same shape if you can turn it 180 degrees or less. All right, so the formula we're going to use is 360 degrees, because that's the amount of degrees in a circle, divided by the number of symmetrical points. And the strategy, the technique we use is just to count the number of points that it could actually turn onto. So for example, this here, we'd have 1, 2, 3, 4. 4 symmetrical points we can use. So if we turn this 1/4 turn, it would be itself. If we turned it again, it would be itself. So in this case, we would do 360 divided by 4, which is going to be a 90 degrees angle of rotation. In this case, we have 1, 2, 3, 4, 5 locations it can rotate to. So this will be 360 divided by 5 is 72 degrees angle of rotation. In this problem here, we have 1, 2, 3, 4, 5, 6, 7, 8. So in this case, it's going to be 360 divided by 8, which is 45-degree angle of rotation. So although there weren't many slides here, there is a lot of information. So I do recommend watching this again until you feel comfortable with all the information presented.